Hi, my name is Cutter Dalton. This is Natalia Warnick, and this is our project on semantically related data orderings for neural network models.
Where the idea came from. The idea was human inspired, and imagine that it's much easier for you as a human and for us to memorize a sequence of things like a grocery list if it's semantically put together. So all the things that we understand better and the things that mean same thing, they are put together. Imagine a robot in a grocery store that is supposed to choose a mango for dessert for you, and you do not want the robot to choose a potato, but a mango. So the idea is that if you show the robot 100 images of mangoes in a row, it will learn easier and better what actually is your favorite dessert and will bring you the desired one. That's the idea of data ordering. Next slide, please. In AI field, the idea and the inspiration comes from curriculum learning. It means that the robot or the AI algorithm sees easy examples first in the training. So the model learns first what is 1 plus 2 is an equation, and then later in the training, as also inspired by humans, later at the in the education level, we will learn more difficult and more complex examples.
This experiment used the news category dataset available on Kaggle, which consists of 210,000 headlines belonging to 42 different news categories from the Huffington Post. Each document of the dataset consisted of a headline, a category, an author, a HTTPS link, and a short description of the article. We ended up only experimenting with the headlines and labels due to training time constraints. We also created manually created 9 superclasses belonging of politics, entertainment, health, lifestyle, family, communities, science and technology, society, and culture.
What are these semantics clusters and how the data was actually ordered? What you can see here are these 9 different superclasses, and under these superclasses, different classes of news headlines. The data ordering was done first alphabetically. So all of the classes were ordered alphabetically, and then it was fed into the model. The second kind of clustering was semantic clustering. So for example, all the articles that came from politics superclasses were ordered together in the alphabetical order, in the descending order, if we talk about number of text, and descending order. And also they were shuffled, but randomly shuffled only within one superclass. And this is what we wanted to check, if the model will learn easier and better when it's clustered within one superclass.
We experimented with the different data orders on 2 model architectures. The first included 2 bidirectional RNNs, 1 simple RNN. Each layer, aside from the final dense layer, utilized a tan-H activation function. The second utilized 2 bidirectional LSTMs, bidirectional RNN, a simple RNN, and a GRU. This model was far more complex and required much longer of a training time. Both architectures were based on the work in the cited Kaggle project. The baseline models which we used achieved only about 50% accuracy in predicting the class. Our corresponding models, which were the same save the variation in data ordering, performed much better. The first model achieved a maximum accuracy of 67.37% when trained on data ordered to mimic curriculum learning. Model 2 performed its best when trained on the same data ordering with an accuracy of 78.61%.
What did we learn from the experiments that were conducted? So the first big conclusion is that understanding is better when news headlines are ordered in general, but not shuffled randomly between different classes. The second big takeaway is that the level of difficulty helps when it's increasing with time, which means that curriculum learning is definitely what helps the model perform better. And then if we want to shuffle the data, it's okay, but within one superclass. So we also saw that the model, the last model, so order number 5, performed better than, for example, alphabetically ordered data sets like order 1 and 2. Um, if it's shuffled, but only within one superclass. And then LSTM and GRU. So what does this mean? We saw that in general, model 2 performed much better. That's because texts are long sequences of words and characters. So LSTM and GRU, these specific models, help to remember these long sequences. And we are very curious about examining many different various data orderings. So we plan to also complete some further experiments in the future.
And these are our references. Yeah, so
Yeah.
thank you for watching. Yeah, I had like an idea when we were or when I was looking at the table of like uh, there seems to be like it really does matter that like the data is ordered in some way, but like I'm wondering if like changing the data order would actually, or on a different data set, like one of the different orders would actually perform better than the fourth one.
Yeah.
Um, yeah, just an idea for future
Yeah,
research.
and another thing that we actually also wanted to try to do, but the time and model constraint didn't let us do it, is modality. So does it mean that also, for example, the image data set is going to make better? Like, I'm very curious about that, if the images would do also much better on image detection or classification. So I'm curious about that. The
Yeah.
headlines were kind of short. So another thing that we could do is doing the same thing, but on short descriptions
Mm-hmm.
that are a little bit longer sentences. So
Mm-hmm.
that would be interesting too.
That would be interesting. You'd probably just have to use the second model because I'm not sure if like the first model would perform well at all with the given the length and like the forgetting. But
Hmm.
yeah. Anyway,
Yes, that's true. It would need to definitely, we would need to improve probably the models. But it was very interesting to see it, and I was very surprised
yeah, I
with
was too, honestly. I wasn't expecting like
with the
78%.
results. Yeah.
Yeah. Okay.